When I was first starting to learn how to code, and even into my early days of my software career, I had a very inefficient way of debugging my code. So when I would see a crash in my code, or when I would see some behavior that I wasn't expecting, basically a bug, what I would do is I would look through the logic of my code and then just try to see if I could find anything that was wrong in the overall logic, and then make tiny changes here in the logic and hope that those tiny changes would actually magically fix the bug that I was experiencing. The reason why I say that this way of debugging was inefficient is because it was based more on high-level speculation about the code rather than actually doing some tests with the code, writing some debug code, and try to capture actually what's going on with the code. If I'm being honest, the reason why I debugged this way was because I was just too lazy. I didn't want to go through the hard work of really trying to understand the code and try to understand the logic, or maybe I was just too lazy to write some debug code to verify some sort of hypothesis that I had about the code, or maybe I was just too lazy to look at the documentation. Like if there was a function call or API call that had some documentation and I was just too lazy to look online and look at that documentation, that's why I would go about debugging this way. There's a term for this kind of debugging, and I would call it hope-based debugging, where you're just hoping that one small fix here, one change here will actually magically fix the issue. The hard part is really slowing down, looking at what's really happening, writing some tests to verify some hypotheses or just to understand the code better, and then checking the logs. And so these are some better ways of approaching it rather than just poking at it and trying random fixes. So in this video, I'm going to go more in depth on this hope-based debugging and why it's inefficient. And then I'm going to show you a better way, which I like to call hypothesis-driven debugging. And then I'm going to go over my debugging framework and give you an example of how I would go about debugging that code. And hopefully by using this framework, you'll be able to debug all the bugs that you're encountering in your own code bases. So my name's Henrik, and I'm here to help you learn the foundations of software development. So let's get started. All right, so here's some example code. We have a function here called sumPositive, and all it does is it just sums all of the positive numbers. And so we have this total number. We go through this array that has this size, and then we sum through it. And then we have a main function here that calls that function sumPositive. It has a data array and then the size of that array. And then it's going to return the sum of all of the positive numbers. So let's run this. Okay, so here's the sum of the positive numbers. It's 11. But if you look at the array, it's going to be 2 plus 5 plus 3, which is not 11. It's actually, that's going to be 10. And so this is the bug. It should be 10, but it's saying 11. So what is an example of hope-based debugging? You would probably, actually what I would do when I was looking at this code is I would start, one guess would be like, oh, maybe something's wrong with my if condition here. Let's just put an equals here and then let's try that. So that's a rookie mistake. You just randomly guess, like just random fix here, see if that changes it and magically fixes it. And so we run it again, and then lo and behold, you get the same answer. And so I just keep trying these random fixes here. Maybe another guess would be to change this part here and make it more explicit. So you do total plus ARR, and then maybe this way is different than the other way, and so maybe trying that will change things. So you run this one, and then lo and behold, you get the same answer. And so this is hope-based debugging, where you just change different things randomly, hoping that this change will fix things. Now these seem like silly examples, but these are just simple examples of more complex examples that I've seen. So this way of debugging not only wastes your time, and not only is it inefficient, but it also gives you less control over the debugging process. And this is where things started to change for me. So when I was working in my companies, I ran into more senior developers, more senior engineers, and they taught me a different way of debugging. And this is something that I would like to call hypothesis-based debugging. So in hypothesis-based debugging, what my coworker taught me to do is he taught me to look at the code and see where could things be going wrong. And then we would test all of those different places. So maybe we have a function here, we have inputs into the function. Is the issue happening outside of the function in the main function? Or is it happening inside sumPositive in the actual function? Or is there something wrong with the way we're passing the data to the function. So we can test all of these different hypotheses, and one by one we can narrow down by process of elimination. We can really figure out where the issue is actually happening. So using the process of elimination, we can see here in the beginning of the program, these are just declarations. There's nothing fancy about that. So we can eliminate the inputs being wrong. So next we can check, is the data being passed into this function correctly? So we can put some print statements here and test that hypothesis. So is the data getting passed correctly? Okay, I put some printf statements here to check on the input to see if the data was passed correctly to this function. So we run this. And this is what we got, sum positive called with size 5. So is that correct? Did we pass it correctly? Yes, size 5 is correct. The array contents is 2, -1, 5, 0, 3. And then somehow the sum is 11. But we see that we passed the data correctly. So that rules out that hypothesis. Next, we can check on this if condition. Are some negative values coming in here that's messing up the sum here? So maybe we put some print statement here. Okay, put a print statement here, and we're going to print all of the array elements that we're going to add to this total. So let's run this one. Okay, so we have array elements 0, 2, 4, and 5, and then the numbers that are summed are 2, 5, 3, and 1. So we can actually see here how it got 11. So we saw that this is 8, 9, 10, and then that's 11. So that explains why we got the 11. So I think we're close to figuring out the bug, figuring out what's going on. We can compare this array with our actual array. And if you look at our actual array, there's 2, -1, 5, 0, and 3. But here we have 2, 5, 3, and 1. So now we have something that's really unexpected. Where did this array 5 equals 1 come from? And so now we have some idea. So now we're really narrowing down, really understanding the code. So now we have this element here that's raising some suspicion. How did we get to this point here? And then we can see, oh, this is actually index 0, this is index 1, 2, 3, 4. So we're accessing an invalid index here. So it's accessing index 5, but this data array doesn't have index 5. It only goes up to 4. So now we can check on our for loop. So for some reason in this for loop, I is iterating and it goes up to 5 somehow. And then that's how we get the invalid index. But we can look at the conditions here and we can see, aha, I less than or equal to size. And we know that size was the number that was passed is 5 here. So we know that this for loop will continue to go in when I is equal to 5. And we don't want I is equal to 5 to be in here. So maybe what we can do next is we can remove this equal sign here. And then we can run this code again and check on this printf statement so that we can see if the 5 index is still coming out. So let's run this one. And then there you go. So we have 0, 2, and 4, and there's no array 5 in here because we fixed the condition here. And then if you look here, you can see that the actual answer is total positive is 10, which is what we expect because in this array here, it's only 2, 5, and 3. And so you can actually see the numbers that we summed up is 2, 5, and 3. So this one, and this one. And now we've solved the bug. And we can remove our debug code now. And there you go. So now we fixed the bug. Now if you want some steps that will help you programmatically debug your program, you can follow these steps here. So step 1 is observe the symptoms. So in this program we saw that the sum was 11. So that was the first symptom. And then we create testable hypotheses. So in this step, what we did was we tried to see if the data was passed correctly to sum positive. That's something we can test and see if that one's working correctly. Then we put in some printf statement here. We had this printf statement here. This is something we can test to see if the if statement was working correctly. And by extension, we also learned that we were able to see if the for loop was working as we expected. And then you test all of these areas. You test one small area at a time. So the first test, we just tested this part here, just the input into this function. So we tested those. We eliminated what was working. So we eliminated this, the input as being the issue. So we know the input arguments of this function was not the issue. So we eliminated that. Then we isolated the problem. And so we saw, okay, maybe well, the total is the thing that's happening that was incorrect. So let's narrow down and see what is actually contributing to the total. So we had this printf statement here, and then we can see what are the actual numbers that were used to generate or to create this sum total here. Then it became readily apparent that there was a index here that was added that was unexpected, and so we're able to, at the last step, isolate the problem. So this was the real problem here. This was how we diagnosed the bug. Is we were going out of bounds. We're going into this index here that we didn't expect. And so what is the fix? So the fix has to be, that's another thing that we would need to, we could follow this steps again to figure out how we can fix it. But this is a really simple example. So we can just say, okay, maybe the condition here was incorrect. And then we remove that equal sign, and then now we get the correct answer. All right, so you can follow these steps here. This is my hypothesis-driven debugging framework. Follow these steps here, and this helps you stay grounded in logic rather than emotion. And this is actually a more lazy way of debugging, because all you have to do is just follow the steps here, and you don't have to do any guessing. It takes the guesswork out of it, and you don't have to think high-level things per se. You don't have to think of these high-level speculative things. You can just follow these steps, and it magically brings you to isolating down to the problem, and then you know what to do. You know where the bug is, and you're able to fix it. All right, like I mentioned earlier, if you're just starting off in your programming journey and you don't know where to start, you can download my 30-day beginner coding challenge. And it's a 30-day guide where I teach you how to build those 4 beginner programming projects. It's really beginner friendly, and I go step by step on how to build each one and go through the tutorials that you need to build each one. So download that in the link in the description. All right, that's it for this week's video. I hope it really helped you out. And if it did help you out, please like, share, and subscribe to the channel. And if you want to watch other videos on debugging, I have a bunch of other videos. You can watch this one over here, and I'll see you in the next video. Peace.